In this video, we're going to talk about how to determine the formulas and names for ionic compounds. So an ionic compound is a compound that are made of ions, a cation and an anion. Now, for the most part, if a compound has a metal in it, then it's going to be an ionic compound. But not all ionic compounds have metals. There are some ionic compounds that are all nonmetals, in particular ones that have the ammonium ion. But if a compound has a metal in it, you can almost be sure that it's going to be an ionic compound. So how do we determine the formula for ionic compounds? Ionic compounds are determined based off of the most common charge that the ion can form. So if you remember, cations are metal ions or positively charged ions, and there are lots of metals on a periodic table. So if you remember, metals are everything to the left of the stair-step line, where a stair-step line starts right here between boron and aluminum, and it just kind of goes down. Okay, and everything to the left is going to be considered a metal for this case, and everything to the right is going to be considered a nonmetal. And so metals will lose electrons, forming cations, and the nonmetals will gain those electrons, forming negative ions or anions. Now, the number of electrons that a metal can lose can vary depending on the metal. Some metals will only lose a certain number of electrons. Other metals can lose multiple numbers of electrons. So let's first talk about elements or the metals that form ions that only form one particular type of ion. And that is all the metals that are in group 1. So these are what we call the alkali metals. In group 2, or the alkaline earth metals. So all these metals right here all will lose 1 electron. All these metals here will lose 2 electrons. The other 4 metals that will only make one type of ion is aluminum, zinc, cadmium, and silver. So aluminum will always lose 3 electrons to form a +3 ion. Zinc and cadmium will form a +2 cation, meaning they will lose 2 electrons. And then silver will always lose 1 electron, forming the +1 ion. So if a metal is in the first group, the second group, aluminum, zinc, cadmium, or silver, it will only form one type of ion. All the other metals, so all of these metals, all the intertransition metals, lead, mercury, all of these right here, they all can form more than one type of ion. So let's first talk about how we name and write the formula of the metals that just form one ion. And so, like I said, it all depends on what the charge is on that metal ion. So we'll start off with a metal that forms an ionic compound from the first group. So let's look at sodium. That's the simplest one. So sodium will form a +1 charge. And so compounds always have to be neutral in whenever you add up their charges. So when we add up all the charges, it always has to equal 0. We go to chlorine. These nonmetals all form negative ions. And the way we determine the number of or the charge on these ions is by how many away they are from the noble gases. So everything in the halogens will form a -1 ion. These will form a -2, -3. So chlorine will form a -1 charge. And so we could have chlorine, which is -1. So +1 -1 equals 0. So the formula for a metal or for an ionic compound that incorporates sodium and chlorine would be NaCl. And the way we name ionic compounds is simply by stating the name of each of the ions. So in this case, it would be sodium chloride. Now, all binary compounds always end in an IDE. So we give the name of the cation of the metal, and then for the nonmetal, we use the root name. In this case, it's CHLOR. So chlor for chlorine. And we always end it in IDE. if we wanted to bond sodium with fluorine, so fluorine is right here, it's also a halogen, so it will form a -1 charge. And so sodium is a +1, fluorine is a -1, and so its formula would be NaF. And its name would be sodium fluoride. Again, we end it in IDE. We give the name of the metal and the root name of the nonmetal. Now let's do another metal. Let's look at K, so potassium. So potassium also forms a +1 because it's in the first column. And let's look at bromine. So bromine is underneath chlorine, and so it's a halogen, so it's going to be a -1. So +1 - 1 equals 0. And so the formula will be KBr, and its name would be potassium bromide. Now what about a combination of elements that are not in the first column or is not a halogen? So let's look at magnesium. Magnesium is in the second column, so that would be a +2 ion. So magnesium forms a +2. And then let's look at oxygen. Oxygen is 2 away from the noble gases, so oxygen will form a -2. And so +2 - 2 gives us 0. And so the formula is going to be MgO, and the name is going to be magnesium oxide. Now what happens if these charges are not equal? Well, if the charges are not equal, then you have to add more of those ions to balance out the charge. So let's look at sodium again and combine it with sulfur. So sodium has a +1 charge. Sulfur is underneath oxygen, and so it's 1, 2 away from the noble gases. And so sulfur is a 2- charge. Now to balance this out, to get this equal to 0, we have to have 2 of these sodiums to balance out this 2-. And so to do that, we need to label it as a subscript. And so we would write Na2S as a formula for the combination of a sodium ion and a sulfide ion. And so we would name this as sodium sulfide. We can do the same thing if, let's say, the metal is a +2 and the nonmetal is a -1. So let's say we have magnesium, or let's do calcium. So calcium is underneath magnesium. So calcium, which is a +2, and then let's do iodine now. So iodine is -1, and so we need to balance out the charge. We have a +2 and a -1, so that means we have to get that to 0. And the way we do that is we have to have 2 of these iodines to give us a total of a -2. +2 - 2 gives us 0, and so the formula will be CaI2, and the name would be calcium iodide. Again, we end it in IDE. We just list the name of the metal, the nonmetal, the root name of the nonmetal, ending in IDE. Okay, let's do one more. Let's do one of these that we did over here. Remember, aluminum has what charge? Forms what charge? It's 1, 2, 3. So aluminum forms a +3 ion. So let's do the aluminum ion, which is a +3. And let's do oxygen. So oxygen is a -2. And so now we need to balance out these charges, a +3 and a -2. So the common multiple between 3 and 2 is 6. And so to get 6, to get a +6 and a -6, we need 2 aluminums. And so it would be Al2O3 would balance out everything, because 3 oxygens would give us -6. And so the name for this would be aluminum oxide. And we would do the same thing for zinc, cadmium. These two form a +2. Silver forms a +1. Now, way I remember this is that we're at the end of the transition metals, and so this is kind of a backwards L. And so the zinc and cadmium form a +2, and silver all by itself forms a +1. Notice whenever we name these compounds, we just give the name of the metal, and then we're basically giving the name of the ion. So this is the magnesium ion, and this is the oxide ion. This is the calcium ion, and this is the iodide ion. And so all we're doing is just listing the name of the ions and eliminating the word ion in the name. So what about all the other metals? This technique only works for the metals that have a lone electron, or only work for ions that form one type of ion. And so there's other metals that can make other types of ions. So for example, iron. So iron has a potential of forming two different ions. So when we bond iron with chlorine, iron can form a compound with chlorine that's FeCl2 and FeCl3. So these are two different compounds. They have different properties. And so how do we name this? Well, we can't just say iron chloride, because are we talking about FeCl2 or FeCl3? Which one are we talking about? So to distinguish between these, we have to put Roman numerals for the charge of the metal. So if we look on the periodic table, chlorine is a halogen. It will always form a -1 charge. And so this chlorine right here is a -1. Total charge is a -2. That means this iron is a +2. And in this case, the chlorine is a -1. We have 3 of them, so that makes it a -3. So this iron is a +3. So this is the iron 2 ion, and this is the iron 3 ion. And we show that in the name for each one of these by using Roman numerals for whatever the charge is of the ion. So in this case, we would write iron 2 chloride. And this would be iron 3 chloride. So again, the Roman numeral distinguishes what the charge is on the metal. So the iron 2 shows us that we have a +2 charge, and the iron 3, the Roman numeral 3, tells us that we have a +3 charge. All right, so if we look at SnO2, SnO2, oxygen, we look on the periodic table, oxygen's a -2 because it's 2 away from the noble gases. So that's a -2. Tin is right here. Okay, so tin is not in the first 2 columns. It's not in the first 2 columns, not aluminum, zinc, cadmium, or silver. So that means we have to show a Roman numeral. So tin is right here. So tin has what charge in this compound? So oxygen's a -2. We have 2 of those. That's a total of a -4, which means tin is a +4. So the way we name this is tin 4 oxide. So again, we just give the name of the metal, and we have the Roman numeral to show us what the charge is on the metal. We only use Roman numerals whenever it's not in the first 2 columns, it's not aluminum, it's not zinc, cadmium, or silver. If it's any other metal, we have to use the Roman numeral to show what the charge is of the ion that forms. If the metal is in those first 2 columns, aluminum, zinc, cadmium, or silver, we do not use the Roman numeral because it's not necessary. We already know what the charge is for that ion that forms for that particular metal. These nonmetals always form a -1. These always form a -2, -3, based on the location or the group, how far away they are from the noble gases. Some anions can be polyatomic. Polyatomic ions are groups of atoms that have a single charge. So for example, sulfate is a polyatomic ion. Sulfate has a formula of SO4 and has a charge of 2-. That means this whole grouping, SO4, has a total charge of 2-. And so we treat this just like we would treat anything in this column right here. So we would treat SO4 just like an oxygen, or just like a sulfur, or a selenium. So this whole group is a -2. So we wanted to combine, let's say, sodium with a sulfate. Sodium is a +1 charge because it's in the first column. To balance out everything, we have to have 2 of these sodiums. And so the formula will be Na2, and then we put an SO4. And the name is sodium sulfate. And so we treat polyatomic ions as a single entity. This whole thing has a charge. And so we treat it all the same. Let's try magnesium. nitrate. Would be another ionic compound that has a polyatomic ion. So nitrate is a polyatomic ion. Nitrate's formula is NO3 and it has a charge of -1. Magnesium is, we try to find magnesium on the periodic table. It's right here in the second column. So that means we do not need to use Roman numerals. It has a charge of +2. And so to balance out everything, we need to have 2 of these nitrates for every one of these magnesiums. And so to do that, we want to put parentheses around the nitrate to show that it is a polyatomic ion. So we write Mg, parenthesis, NO3, and parenthesis 2. And so this tells us that we have 2 nitrates for every magnesium. We have to have those parentheses there. If we don't have that parenthesis there, it would look like we would have 32 oxygens then, and we don't want that. So we want 2 nitrates for every magnesium. Now let's do one with a Roman numeral. Let's say let's do sulfate again, and let's combine it with copper. So this time let's just write CuSO4. And so SO4 is a sulfate ion, and so that has a -2 charge, okay? And I just put the parentheses there to show that that is a grouping altogether. Normally we don't put parentheses there because it's all 1 to 1. And so that means this copper has to be a +2 charge, because +2 minus 2 equals 0. All right, so that tells us that copper, which is right here, it's not in the first 2 columns, and it's not aluminum, zinc, cadmium, or silver. It's above silver, but it's not silver. And so that means copper, we have to show a Roman numeral. And so what Roman numeral? Well, it's a +2, so we have to write copper 2, and then we write the polyatomic anion, which is sulfate. So the name would be copper 2 sulfate.